Hey Jess and Case, I thought I would show you, since we didn't have a chance to do this before you left, what the structure for motion looks like. And it seems like it's really difficult to do if there's a lot of background. So I was really hoping to take this from largely architectural or laboratory use to something in the field. And it would be really neat if we did thermal images because we could actually look at sort of the physiological expression of the whole plant rather than the structural expression of the whole plant, or some combination of both, I suppose. So what I did, just for the purposes of illustrating for you, is I put an orchid, one of our orchids, on a table in the middle of the living room, and I went round and round and round and took a bunch of photos. And then I ran this program, which is called Visual Structure for Motion. And what it winds up doing is looking at each of these photos and trying to figure out how they're related to one another. And it can quickly do so by identifying different landmarks or key elements in the photos and then seeing how they change from image to image. If they shifted left or right, that's pretty easy. If they shifted in 3 dimensions, then it has to calculate the angular shifts as well as the left and right shifts, so how it shifted in 3 dimensions. And then it goes through this elaborate process of putting all the photos together. And when it puts them all together, it then uses them to construct a point cloud. So it constructs a point cloud the same way the LiDAR does, but it's based on very different kinds of visual information. The LiDAR is looking only at one wavelength, bouncing back and forth, and practically delivering the points one by one by one by one to the recorder. This is actually trying to derive what the points might be from very complex images made up of multiple wavelengths, which is nice for many, many purposes, but for ours it's a bit more challenging. In part, I think, because the thermal images are sort of soft and don't necessarily have the kind of clear structure that you would see in these visual photographs. Nevertheless, I thought if we could do it, it would be really neat. So what I'm going to do now is switch to the other screen to show you what it looks like. Okay, after some calculations, it actually runs for quite a while. And you'll notice I don't think I have more than maybe 40 images here, and I said to you in an email that I think we need a lot more for something as complicated as a bush. And you can see what the program did here, and I'm going to move it around, and you can see that it actually figured out how all the photos are related to one another. And you can see that basically it decided that all these photos represent a kind of a dome that was looking at a bunch of stuff from many, many angles. Notice these lines here shows the angles which they think the camera was lined at. So they think the camera was here and it photographed a picture. The camera was here when it photographed the picture. And it's pretty remarkable. I mean, I think the mathematics is pretty straightforward, but I find it sort of magical, as I bet you do as well. So you can see when I went round and round, I did kind of not get a gap here, and there's some other spaces. I remember to go on the top and to go to the side and go around here and there. And if I rotate it, you can see there's a gap there. When this is done in a laboratory, it's often done with a robotically controlled turntable and camera. And then the positioning is actually very well done. Now you can see a little closer here are some of the images. Isn't that cool? So of course what happens in this case here is that the camera very quickly picks up on features which are rather prominent. Now one thing that's relatively prominent is the carpet here. So if we zoom back and look at the point cloud, it really picked up a lot of points associated with that carpet, which is not terribly interesting to me. And then fewer points, it actually is seeing that there's furniture around the room. So you see these here, that's probably the sofa. There's the sofa. You can sort of see there's an armrest, a back, there's where I'm sitting. And of course, what I'm really interested in is this table down here. So there's the point cloud for the table with the orchid on it. That's all I got. Okay, now that's not a lot of data to work with. But still, nevertheless, I think it's pretty magical the way it does it. Now, my idea with this was to try to see if we could use this in the field. And we would certainly get, a lot of this stuff on the ground here. But we would get the bush here. in all its structure, and we would be able to spin around and see, for example, if the light is shining on this side when you took the pictures, that most of the physiological activity of the plant is over here and is less on that side. Cloudy day or a cold day, we probably wouldn't see very many differences among the leaves. Right now, though, there's the table. That's the little table, and here's the orchid down there in the middle. So I was very excited about being able to do this. It's not a this is a open source software. So it's not terribly friendly. It tends to crash a lot of the time. The user forums are basically done by people who are incredibly well informed about the process and the software and all the different tools. And so they speak in a structure from motion lingo that I do not follow very well. Nevertheless, it seemed to me that we could get this far with it. So I hope this helps get you a little sense of what it is I'm trying to do and why getting the sort of dome of pictures around the bush is pretty key. Now, whether we'll be able to use this in the field, given all the background stuff that winds up, being a distraction, is another question. Because we could stand there with somebody holding a black cloth or something in the back and moving opposite from the person taking the pictures. But I don't want to do that. I just want to go out there and get cool pictures by this process. So I hope this helps explain what it is I'm after. And you can sort of see that once we have that cloud point, there are tools up here that can, and other programs, that can generate the sort of geometric clouds, from the points, shapes, and actually calculate volume and so forth. But imagine in this case we would get things like volume of physiological activity or volumes of heat, which I think would be very, very cool. So thanks for trying to do this, and I hope this helps. Take care.